Everybody, thank you for joining. A couple things. So today is actually this is the fourth one that we've done, um, and I'm actually pretty excited today. So what we have is we have Ronald Butler who's on the phone as well. So I appreciate everybody who's been coming. I think what we've been doing is talking through waste and recycling facility fires, scope, consequences. But I think one of the big things is we always talk about this lithium-ion battery and why they fail, how they fail. Um, and I think one of the things is a lot of people don't truly understand really why a lithium-ion battery explodes and what they do. So, yes, Sean, I actually think this is a HIPAA violation, or at least it was. So, thank you for pointing that out. Um, During this is supposed to be interactive again. So, if you have questions for Ron, you have questions for me, let me know. What I'm going to do is kind of talk through the first few minutes. I'm going to get into kind of what I'm seeing from from a COVID-19 and what we're seeing as far as um, as far as fires in the industry. I've been actually reporting week by week now. I haven't reported it anywhere else, so I'm actually going to share that on the phone with you guys. And then we'll get into, really, Ronald's information is great. It really gets into the basics of lithium ion and why they do what they do. And also, I think a big thing that Ron will talk about is the supply chain, the full supply chain, right? We're only one piece of the recycling side of it, the waste and recycling side. And I think there's a really big market out there. We're really more the personal storage piece of the business. The lithium ion batteries you're seeing in calculators and AirPods and phones, right? Where there's a really big piece of the lithium ion supply chain from the automotive OEMs that is actually doing a really good job, just like the lead acid batteries we're doing as well. So with that being said, I wanted to tell you guys as well. Next week, I have Jim Emerson. He's the engineering manager for Star Technical Risk Agency. He was formerly of FM Global, formerly of AIG. He's actually a fire, electrical, chemical, and civil engineer. So he's one of those. When I say engineering manager, I think it undercuts what he does. He's had a ton of experience. He works for one of the large insurers, and he's the guy who comes in and does your risk mitigation audits. So him and I developed a combinational approach to firefighting that was focused on waste and recycling facilities. A few years back, it was published in International Fire Journal, and we actually have updated that. So we're going to do, the combinational approach, basically 2.0. So that'll be next week. So if you are interested, if you could reply back to me, that's awesome. Again, my goal is not to spam anybody. So if you don't want to be invited to something, just please let me know. I'm more than happy. And also, like, we're not an association. This isn't obviously a full-time job. So at the end of the day, if anyone is interested in learning more or has feedback, feel free to share. Honestly, I'm doing this because I believe that there's people out there that are interested, and I mean, I think from the attendees that we've been getting, and especially people who've been watching and looking at the recordings after they're over, I definitely think there's a need for the knowledge. So, the scope of the waste and recycling facilities, I'm not going to get into this in depth today. But really, I think, in March, what I want to talk about is specifically about March and what's happened because of the stay-at-home orders. This is the numbers that we've seen since 2016. Again, I am only reporting reported fires from waste and recycling facilities. So these are only facilities. They don't include landfill. They don't include trucks. And they are only reported fires. So this was reported by a media outlet somewhere in the US and Canada. So, and again, there's based on reasonable assumptions. There's a lot of reasons. If you want to look at last week or the week before, we can, you can see the in-depth detail. And if you're interested in my annual report for 2019, happy to share that with you as well. And it's also on my LinkedIn. But I think this is where we're seeing there's so many trends that again, everyone says unprecedented times. I've almost heard it way too much, right? But with that being said, the we are in unprecedented times, and I think like last week we didn't see, like, the first week of April there was one fire. Period. I've never in my 4 years, 4.5 years of doing this, seen one fire incident. Period. So again, it's whether maybe the reporters were on furlough, maybe everything was kind of getting ready. we really don't know what the true answer is. So, again, I think this is the scope of the problem. But if we go into, March's numbers versus last year, waste and recycling, the numbers were up as the number of fires, even though the number of incidences overall were down. So again, I won't get into all these. I have an article on Waste 360 if you want to read through it, but just due to all these things that have happened, the 100-year cleaning, the school closures, the lack of spring break, all these stay-at-home orders, a lot of the material is going from, it's transitioning from commercial to your curbside. And so, from my perspective, we always see a spike in Christmas time, but typically there's like a lag. So, we'll see some fires in the end of December, but January typically gives us a lot of fires. So what is the effect of, people who cleaned out their homes and have lithium-ion batteries that they've now cleaned out for the first time in, 50 years, 30 years, 20 years, 10 years, all the old computers and all those things. And, again, I only reported fires, but we've seen fires in waste and recycling, just being the fires that we've put out through Fire Rover. I'll share one of those videos later. But this week we had another 9 fires. So again, first week of April we had 1. This week we had 9, and of those, 5 of them were waste and recycling. So that starts to get to, the it starts to get back to normal, right? Normal is 7 fires, and again, we don't like normal. I'll get into, like what the issues are, but with that being said, I think, it's one of those things where when you see 0 fires, I know something's wrong, just as if I had seen 14. So again, typically when fires slow down, we start to see more happen later. So again, we do know that transfer stations and waste facilities, there's a lot of recycling operations that have been either slowed down due to like spacing and other pieces, and they've changed their operations. I think now we're starting to get into back to, I don't want to call it normal, but again, the new normal of, how you're going to be able to pick out and sort the contamination out of the waste stream. So with that being said, again, ton more information if you guys want to see it online or on LinkedIn, but I'm going to introduce Ronald Butler. Ronald Butler is, he's with eCell Secure, just changed his name from ESSPI. So if I mess up that name, I'm going to have him start through, and I'm going to introduce Ron right now. Ron, if you want to go through and just let me know when you want me to move through the presentation from each slide.
Got it. We'll do a quick mic check if I could. Can everyone hear me? Can you hear me, Ryan?
Yeah, no, we can hear you great. I don't hear any feedback, so I think we're good.
Excellent. Firstly, thank you for allowing me to take some time with you and your listener viewers to talk about what I consider this very important subject matter. Let me also say that I think what you're doing is exceptional. Having worked in this space for the last almost 8 years, relative to lithium-ion and lithium batteries in particular, there's been a lack of this type of outreach. These fires happen all the time, and as I look at your numbers, the thing that comes back to me consistently is underreporting. I was a member of the fire service for 25 years, Detroit firefighter for 23 years. My company, ESSPI, was deeply involved in battery safety throughout its entire life cycle. We've moved that into eCell Secure, where not only are we involved in battery safety vis-a-vis better training interventions and consulting interventions, but we also look at really safe ways of physically collecting, transporting, and storing batteries throughout their entire life cycle. So you can go ahead and move to the next slide, my friend.
Sounds good. I'm sure I'm going to screw that up. So eCell Secure, and then we're going to get to your partners. There we go.
Yep. I cannot see it.
You cannot see my slide screen now. Okay, let's try this again. I tried to use the slideshow.
There we go.
Okay, so you were able to see that, but here
I'm able to see that. The guy with the big shiny head, as you can see on your camera as well, is me. If the sun, the little bit of sun we have in Detroit right now, begins to glare off the top of my head, please let me know. It just disappeared again.
Yeah, can you see now?
Nope.
All right, let's try it now. Perfect. All right, there we go.
Okay. My co-founder is Dennis Atkinson, a good friend of mine, a great business partner, and in my mind's eye, and I'm sure his mind's eye as well, a brilliant man. Again, ESO Secure is dedicated to finding better ways to control safety batteries throughout their entire life cycle. This includes logistics, this includes storage, this includes manufacturing, this includes recycling, very importantly, and everything in between. Next slide, please. These are some of our partners who we've worked with on the academic side as well as the business side. Most recently, we completed a FEMA-funded grant with the National Fire Protection Association, Underwriters Laboratories, and the University of Texas, where we did a deep dive into the risk issues involving lithium-ion batteries and firefighters as they respond to energy storage system failures. Will indeed forward Ryan some of that information so he can send out to his viewers. We have a YouTube channel where you can see some exciting burn videos. Everybody loves to see things burn and explode. So through this channel, you'll be able to see some of our work and access some of the data. Warren Buffett is one of my favorite, and I think when it comes to risk, we really need to understand how to quantify risk, what this risk means for us, not just individually and organizations, but as entire industries. It's very important, certainly vis-a-vis lithium and lithium-ion batteries as they flow through this life cycle I mentioned, that we quantify the risk so we can better control it throughout. Of course, post-use or recycling, for lack of a better term, is where some of the risk issues really occur. We have some data to show that. But before I move into this slide, let me just say that I'm a big fan of lithium-ion. I'm a big fan of lithium. I think they're great technologies. Failure rates are still very low. They represent to me not just the current state of industry, but a future, good ways down the road, as we power everything from automotive, electric vehicles to energy storage systems. I think they're great technologies, and that comes from the safety guy. But I'm not under there's no illusion that they don't have problems. They're like anything else in life. We have problems, but as long as we identify those problems and prepare ourselves to mitigate better, we can control the outcomes in a better fashion.
Are you walking through? Do you see the life cycle?
Yeah, I can see it now. Absolutely. We look at the life cycle. Actually, we call this the eye model, as in our eye, because it allows us to watch the battery all the way through its life cycle. We can point to a beginning. Some people would say the very beginning of this life cycle is pulling raw materials out of the ground. But there's very little risk there. There's higher risk as you begin R&D and testing because you're pushing batteries to their limits. As you move into cell manufacturing, battery assembly, certainly for automotive and personal electronics, a component assembly, distribution, and all of these represent stops. R&D, battery assembly, component assembly, they represent stops. But in between those stops are transport and storage, the logistics process, where we find that there are risk issues to be addressed. As we move through the distribution chain to the retailer, to the end user, the real problems begin in earnest after the batteries themselves are disregarded. Whether I'm collecting them at a box store or electronic store and distributing them through the recycling process, that's where we see spikes in failures. And those failures can, which we'll talk about shortly, can manifest themselves in fire and explosion. Still, the risks are very low. We don't want to create undue fear, uncertainty, and doubt. But the risks, if they're not controlled properly, can be catastrophic, and that can be damaging to industry and individual organizations. Next slide, please. So we developed a series of educational shorts. We understand, certainly at this time, that it's very difficult for people and organizations with busy schedules and ever-changing schedules now to take 8 hours of their life for a one-day training on energy storage systems or battery fire emergencies and emergency response protocol development, etc. So what we've done is broken that up into half-hour shorts, short training that people can sit through. Certainly, thanks to Ryan and his organization for putting this together. It's a platform for delivering this type of information. We call them 101s.
So now we get to the
This
fun.
is yeah, you can run that video. This is a fire event in Ohio showing a FedEx truck delivering lithium-ion batteries that caught fire. This was what most would consider a major incident because it involved that truck. No one was injured and the fire was quickly controlled. The problem is whether it's delivery of new battery commodity or batteries being moved through the life and stored through the post-use or recycling life cycle. These type of risks exist. Again, if we don't identify the risk, manage the risk, we can't control them in the long run, and it hurts the industry as we move forward. As part of our shorts, we can start with identifying what thermal runaway is. And a simple definition is that the battery creates more heat than it can give away. When human beings exercise, we have a method built into our bodies that allows us to dissipate heat. It's called sweat. Well, batteries don't sweat. When they heat up, whether it's through a short circuit, someone punctured it, begins this thermal runaway process that we're defining. The heat only grows dynamically because the heat energy stays inside of that battery. As that heat energy grows, the thermal runaway process or definition becomes worse as we move forward. And the next slide will show that. Now, this is there are people in the industry who argue that these numbers aren't exactly correct, but the precise data is not the goal of these educational shorts. The goal of the educational short is to show that there are stages of failure, such that we will see early stages of failure, overheating, the beginning stage, the second stage of failure, which will be a visible, what we would associate with a failure, smoke, flames, sparks emanating. As we move forward, we can have explosion and open flame. From a fire service perspective, I can tell you that firefighters are very comfortable with dealing with the fire component. We have the tools, we have the experience to deal with that. What we're never comfortable with is explosion of any sort. If you store your batteries, whether it doesn't matter what stage they're in, it doesn't matter what stop on the I model or the battery life cycle we're in. If you store them incorrectly, that risk rises. The potential for explosion and fire failure rises as we move forward. Next slide, please. You are the man. You got this video to run?
Yeah, I did.
Ryan,
Hey, listen.
you're the guy. This is a video from a failure at a recycling center in British Columbia. I believe it was 8 years ago. Of course, a general rule is it starts with one battery. Batteries, 400 batteries in a containment environment, recycling containment environment, don't simultaneously short or fail, burn, explode at the same time. It starts with one. When one goes, they all go. That's a good rule of thumb to live by. But you can't control the one, you have to control the all. As you can see, what you can't hear, you can see the visible outcome, the visual outcome of this fire. It's massive fire. Out of fairness to the company, we won't mention the name, I think the company did and still does a great job relative to safety. As a matter of fact, I think they're one of the best. This was unfortunate and one of those things that can't always be controlled. But we have the opportunity now that we know that things like this happen to control them as we move forward through mitigation efforts, better emergency response procedure development processes, standard operating procedures, and then tools for actual fire suppression and containment. What you can't hear, you can see the sparks coming off the flame. I hope I'm describing this effectively. What you can't hear is the popping noises, and the popping noises are actually each individual cell releasing, going in an extended stage of thermal runaway. Some of the signs, as you will see, are pressure increase, which again leads to potential explosion. Temperature increases. Infrared systems can detect that early on in the process. Venting problems, vent gas ignition. The gas is actually the thing that burns. When a battery fails, it releases gases. Those gases ignite, and just like anything else, that's what burns. Content ejection, again, is the explosion issue. Explosion is one definition. There are others, but it's the rapid release of energy, such that shrapnel could be ejected, and people can be injured in that way. I just lost that screen.
Yeah, and the reason I did that was because somebody had made a comment, but I wanted to show you. This was actually a lithium-ion battery, that was a lithium-ion battery trucks that were dumped onto a transfer station at one of my customers. So this will show you the exact same thing, but this is literally 100,000 lithium-ion batteries. They were actually like accidentally dropped into a transfer station tip floor. This is one of my customers that had to literally deal with this. They fortunately caught it, but you can hear the popcorn sound, right? You can hear the same, type of issue that you were dealing with.
Mm-hmm.
So, okay, let me get back to your slides.
While you're doing that, a good way of looking at batteries, and I know a lot of folks on this call are in the recycling industries. They're going to see packs, you're going to see cells. Every battery starts with a cell. That's the smallest component of a battery architecture. The terms change in industry, but it all starts with the cell. Usually those cells fail individually, and the failures, whether by heat or open flame, propagate to consume other batteries, and that only grows dynamically.
Okay, let me play this, and I need to get, hold on. Sorry.
This is this is an interesting video. It shows you, and this is real time. It shows you how fast a battery can fail. This is actually a robot, a NASA robot under test, and one of the lithium-ion batteries failed and spread catastrophically to the rest almost instantaneously. So you can imagine in an environment where that's not the only battery in storage. I have that battery stored with 1,000 other cells, 1,000 other modules or packs. That's only going to lead to additional fires through the process of spread or propagation. So we can look at that initial fire as kindling for the rest of the problem moving forward. An example would be a shipping environment. If I have 500 battery packs or small battery modules on a train, which has happened, and one goes into thermal runaway, by default we can make an assumption that the others are going to be consumed at some point, unless we intervene in some fashion through fire suppression, or that battery has an opportunity to burn itself out, so to speak, and does not spread to other batteries. I guess a really effective mitigation process would be to include, because we can't rely on the fact or the potential fact that that battery might spread to others or might not spread to others, but we can rely on something concrete like fire suppression interventions and better containment systems.
Hey, Ron, we have a question. So Megan, can you unmute and ask your question?
I think so. Can you hear me?
Yep, we can hear you great.
Hi, Megan.
So, hey, I think as you continue to talk, it made it more clear, but a couple slides ago, you said when one battery goes, they all go. So even if the other batteries in the proximity are intact, they're so highly flammable that if one ignites, they will likely ignite as well.
I think what you just said is very key, likely or potentially. When one goes, they all go is a fire service rule of thumb. It does not mean that that's going to happen. And I think that's a great question. It does not guarantee that the fire will spread to consume other batteries in this environment, but we can make a reasonable assumption that the potential is high.
Well, and again, I think there's another question. Can batteries go into thermal runaway when not connected to a live circuit? And I think, I mean, I can answer that. I mean, so basically, I think a lot of the facilities that we're protecting now have battery upon battery upon battery, right? So even if they're not connected to a live circuit, you're still, the heat of the other fires are causing these to go off, right? So again, I mean, Ron, can you answer the question as well in your words?
Yeah, they don't have to be in a state of formal discharge. An example would be there was a train fire in Houston, I believe it was 4 years ago. The train car was carrying small format electronic batteries post-use for recycling. One of them, of course, goes into thermal runaway, consumes them all. Pressure builds up in the train car. At least that's our hypothesis. And the train car explodes. If the folks on this call get a chance to Google Houston train car lithium-ion battery explosion, they can get some background information, and it might be worth us talking about in the near future, some of those incidents involving lithium-ion batteries in the recycling process. But that just goes to show that when one is involved and it has an opportunity to spread to others dynamically, this is not a linear process. It doesn't go to one battery and then the 3 batteries and then the 4. It spreads dynamically to consume all of them if it gets an opportunity. Again, that's not a guarantee, but I think it's a reasonable we can make as we begin to develop out really good mitigation strategies.
Right. I think, I mean, so one of the things, like, we're protecting one of the large automotive OEM recycling, and again, like the real chance that you have of putting a fire out that is due to a lithium-ion battery is hitting it before thermal runaway, right? So if you can catch it in the lower stages that Ron was talking about, if you can catch it when it's lower, you have a shot. And then you can also protect the collateral batteries from, so we use like an environmental friendly foam or environmentally friendly encapsulator agent that hopefully, if there's any room in between, we put those through so that it slows that heat process down. So again, that's really why, the solution that we've developed, it actually, it's unique to the Fire Rover solution, and I'll get into it a little bit later. But, again, the goal is get it as fast as possible, figure it out as fast as possible, and then take the battery that's bad and try to remove it from the rest of the operation, which, of course, if we wanted to, if you could, have 100 feet in between, and I mean, Ron can get into this, but, there's laws that are coming in where, they're looking at us in the waste and recycling industry saying, okay, are you guys going to be required to, have a separate room that only holds lithium-ion batteries, right? Are you going to be required to have a separate room that's off of a building, right? I mean, Ron, can you get into that a little bit?
Yeah, I think I'm glad you brought that up. I think we'd be really, really well served to almost do an entire episode on coming standards, the pressure and the outside pressures that will have on industry. But I can address that really quickly. Yes, some of the rulemaking that we're anticipating could have the potential to be very oppressive to business. On one hand, I can speak only for my organization. On one hand, we understand that certain tools need to be in place to control what you mentioned was an incipient phase fire, to better control that. But we don't need 200 feet of separation on physical piles of recycled batteries. That would be too expensive for the industry to maintain. So we have to come up with other solutions, better ways to meet the spirit of the coming standard without having undue burden on industry. The one thing I did want to bring up is in the video of the NASA robot fire, I think there's some embedded lessons we can learn. Thanks for going back to that, Ryan. I appreciate it. There's some lessons we can learn. An absolute no-no is for someone to grab a fire extinguisher without proper training and to intervene physically with that failing battery. These things are too energetic, and the batteries used in that robot in particular are large format batteries. Look at the jet of the flame projecting 4 feet, 5 feet. the heat is intense, toxic gas release, potential for explosion. A really good SOP would not have that person grabbing a fire extinguisher. And by the way, that is the absolute wrong fire extinguisher for lithium ion. And I can get into that on another day. But there's so many things that, you know, I'm not being overtly critical because there's potential for loss of life and injury. I would you know, emphatically say that people should not be intervening with these things.
Yeah,
Rely on
I mean,
automated systems.
I'm going to
Rely
agree with you
on better
100%.
controls.
Sorry, I'm going to agree with you just because I do try to stress this in every presentation that I do, that literally fire extinguishers are not made, and I'll show a video in a few that really hits this home, that, you know, you need to have the encapsulator agent, you need to have something that's been created for these types of solutions, right? Not just a standard fire extinguisher.
Yeah, and if whatever solution you determine, it has to cool the battery. The goal is to push that thermal runaway process, that linear process we showed, which is actually a dynamic process, back towards zero. That's the goal, to eliminate that heat energy, to try to eliminate the flame, and you know, in the process, prevent other batteries from going into thermal runaway. Be surprised, by the way, how few firefighters in the country are trained properly dealing with things like electric vehicles and energy storage systems. We're working on it. We're trying to get these things in place, but firefighters included are not very aware of how to properly deal with these things. Certainly, large format batteries in volume.
Well, yeah, and I mean, to extend to that, I mean, I think we've discussed, I mean, you know, the firefighters are being told when lithium-ion battery fires to actually take a defensive approach. So, you know, we have a solution where we put a manifold on the outside so the firefighters can actually still fight the fires, but from a safe distance, typically outside the building. We have a question, can batteries go in? No, sorry, that wasn't it. What's the fuel that's burning in the Nassau fire? Or the,
Uh, you know, I don't have detail, but what I can do is base it on what we see. We don't know the chemistry of the battery, you know, but for most intents and purposes, and I have to stress, most intents and purposes, of course, there's data that would support an argument either way. But for the layperson, we can assume that it's lithium ion because it's rechargeable, potentially is rechargeable. And the family of lithium ion batteries under duress or in a fire explosion situation behave roughly the same. And I try to be as emphatic about that as possible, roughly the same. So because firefighters, you know, there are, you know, 20 subgroups in a family of lithium ion batteries. I can't have a firefighter fighting intervention for each one. I have to be able to treat them the same for the most part. So when they burn, gas is released as an ignition source. Just like anything, material doesn't burn, gases that are released from material burns. If it's wood, as the wood heats up, you know, vapors are released and the vapors burn. Gasoline doesn't burn per se. The vapors above the gasoline are escaping from the gasoline burn. The same is true for lithium-ion batteries. When they vent, it's the gas, the fuel, the gases that are actually burning.
well, no, and as you're doing this, I just, you know, because I think it's probably better. I mean, I think everybody's really enjoying this, so I'm just going to show a video, just kind of intermittent, because we also do have a question, but this was the one that I was showing you. This is basically a this is a tipping floor, an infeed conveyor, and so basically, you know, we have these set up so that it'll actually shut down the conveyors when there's a fire. But what you're going to see here is the two standard fire extinguishers that were basically placed. So what you're seeing here is two extinguishers that are being sprayed, and as you can see, it's poking the bear, right? These are not using, you know, the wetting agents that we use. And again, you're going to see this. I mean, it basically makes a mess, right? And then we come in and we start to shoot the fire rover system into it now, you know, once the guys were safely pulled away. So, you know, again, not just, you know, I think you had said, I mean, the goal is to, you know, fight these as remotely as possible, right? And of course, a sprinkler system was never developed to fight an early stage fire like these and like they're needed. So, you know, again, I think this is where our system has been, you know, becoming more and more prevalent. Dave Rivas, you have a question? Would you like to ask? David? Okay, well, I think he's gonna. David Rivas, you have a telephone call. All right, so I'm sure he'll ask it in a minute, but so let's get back to the failure modes.
Mhm. Before I get into this, just so I think it's unfair to present problems or to outline problems without providing potential solutions and places people on this call can go to seek out additional information. There are two organizations, and I am not a member of either. There's really no impetus for me to boost them, but I think they hold the industry together relative to knowledge and understanding. One is the PRBA out of DC, Rechargeable Battery Association. They do a great job of continuously seeking out resources for their members and the wider battery involved community. The other is the Responsible Battery Coalition. They're also out of DC, and I think they do a great job as well. When you move forward, regardless of what industry sector you're in, whether it's automotive, pure recycling, et cetera, the need for resources is always there. And we have to constantly look to, not just through presentations like what Ryan's providing, but also deeper pots and pools of resources where we can make better decisions on how to protect our industry and organizations. Failure modes. Batteries can fail in another way, and I don't think we have that video. Do we? Oh, there we go.
Yeah,
Thank you, man. This is a nail penetration test. And you can see for us older folks on here, I know the young folks won't know what Jiffy Pop is, but that looks like a Jiffy Pop bag. And as soon as you make contact through those layers in that battery, and I get into detail, the battery fails and goes into thermal runaway. So it's instantaneous. That can happen with a forklift. That can happen as you're pushing batteries around in a recycling bin. That can happen at any process. That can happen in assembly with new batteries. That can happen at any time during the battery life cycle. Of course, during recycling, these risks are elevated.
Did you want to go to the next one?
Yeah, please. I'm sorry.
Oh,
external, the short circuit charging and discharging process. Putting a battery in I'll give you an example. There are rechargeable battery kits out there. You can put AA sized batteries, rechargeable batteries into a wall outlet and recharge it. Don't see them a lot anymore. But if I put a standard battery or NiCad battery in there and attempt to recharge it, then I have a problem. If I put a standard battery in there and try to recharge it, it's going to result in a failure. Discharging and charging rates. If I'm charging a mobile device at a rate that wasn't designed to be charged, I can expect some problems. Also, discharging. People are unaware that discharging is a problem. And every time I leave my phone is sitting next to me now, and it's discharging by default. There could potentially be problems there. If we can in another training, we can get into some of the signs that a failing phone will show, but there's always problems there. You can go to the next slide, Ryan. Over discharging, that's another one. People never expect that you can over discharge your phone as you run it towards zero, but it can happen. It's very rare, again, but over discharging can be a failure mode as well. Next slide, please. This shows, actually this is a automotive battery that's gone into overcharging. So they've purposefully overcharged the battery and sent it into thermal runaway. But it's hard to quantify the size of these. Imagine a vehicle battery pack at 600 pounds with 4 of these in it, 5 of these in it. It's a massive what we call a battery. Some companies call it a pack, some people call it a module. Some people call it a battery. This pack can be extremely energetic, and as you can see, once one of those cells fails, it quickly spreads to the other. But the issue here is overcharging. charging beyond its limits. Next,
Well, yeah, yeah.
excuse me.
Just to kind of throw this out, I mean, and it's interesting. So if there's anyone on the phone from NFPA or any of the fire engineers, I think Bruce is on here, but basically, we're looking at an airship that is literally powered by a lithium-ion battery, right? And like, it's the size of a table. So, if you look at NFPA and the 409 code for the hangar protection, they're looking for dilution because the fire that they're trying, or the risk that they're trying to mitigate, is typically the jet fuel, right? Where, the codes haven't caught up to these. So now you have this risk, which is basically there's no other risk in the entire, hangar except this, right? And this is small compared to the one that we were looking at. So again, it takes a completely different approach to trying to fight these fires.
A great point, and I'm glad you brought up the NFPA. I worked with NFPA and a very talented group of subject matter experts to develop battery fire response for energy storage systems. The large format, how do we deal with them? We started at the beginning. There's not a lot of standards to hang our hats on 3 years ago. Now we're moving. We have NFPA 855 for energy storage systems. There are some UL standards for battery ownership. We're working on UL standards for battery transportation and storage. But we're at the beginning stages. Society of Automotive Engineers has a battery transportation group that does really good work on helping automotive partners quantify the risk and protect themselves, not just themselves, but their partners in the logistics process.
Well, yeah, and I think from a waste and recycling facility perspective, right? I mean, I think, we're trying to figure out if batteries are going to fall under electronic recycling or as hazard materials and it's basically a state by state decision, and it's kind of going back and forth. I know, Ron, you could probably give some insight to that. So, I'm actually working on NFPA, the hazard material code, right? But it's one of those that, it's kind of up in the air. Are we dealing with these or are we not dealing with these? So, and again, I don't think that, I mean, it's probably going to take a few years to figure it out, but as everyone on this can probably imagine, it needs to be figured out, right?
Absolutely.
Hey,
Absolutely.
can I ask? So we did have a question, Ron. So outside of of an encapsulator agent that we use, the F500, like what's the best suppression agent for these types of fires? And he's saying CO2, halon, Lithex.
You really want to get me in trouble, don't you?
I mean, I don't personally. No. And again, George Kirshner is saying that water is the most effective fire suppression agent.
Oh, hey, George. I hope everything's good. George is a good guy. George actually leads the PRBA I mentioned earlier. Funny he's on the call.
All right.
I agree. As we move forward, we have to be able to triage, in essence, suppressants and suppression methodologies. If we're going to look at it at base, we can start with the capacity to cool, and water cools. It's readily available. It's easy to apply. Now, maybe we can add something to it, a 3% mixture of something, encapsulated agent maybe. I don't know. But you start with cooling. You have to be able to push that thermal runaway number from the high 400s to 1700 degrees back towards zero. There's debate. There's a lack of really good testing on what suppressants really work. There is some data available. But we could start with water. I would say that things like what you just saw in the NASA video, dry chem powders, CO2, not good in my book because they don't cool. But that's based partially on data and research, and partially on what I've seen, and partially on my opinion.
So yeah, no, and I think it makes sense, right? I mean, from our perspective, again, like the Fire Rover, we're agnostic on what we use, right? So I can use just water, right? We still have the same, we do choose to use the encapsulator agent. I mean, again, with the rubber fire, right? We were able to put a rubber fire out, a 3,000-degree rubber fire in less than 4.5 minutes before the fire department was able to even arrive on scene, right? So again, we've had really good luck with it. We've had good luck with it on lithium-ion batteries. We've had luck with it, and again, I have video after video that we can show with these. So, I do believe that if someone said, okay, hey, we have to use this, I think, Ron, you're the one who had told me that, you know, that when they're bringing batteries over on ships, they just dump it in the ocean. So yeah, of course, water is going to work, but how much of it do you need? And how fast does it work? I guess all of us need to understand. And I mean, I know I'm not the person who's going to make that or figure that out. I don't think you are either. So maybe George
No,
knows of a few of those guys.
I'm glad George is on the call. The way I look at things, my company, for example, we design battery transport and storage systems. So we not only do we have containers, 20-foot, 40-foot, and even, you know, smaller containers in which we can put batteries. If there's a failure, we can control it. We can communicate to a third party that there's a problem through, you know, wirelessly through the cloud. We can bring active fire suppression, passive fire suppression to bear, so that doesn't become a bigger problem. We can contain it and control it. What we choose to use as a suppressant is always in a state of flux. It really depends on the application. There are some applications that we can control an environment through a locker system or cubbies in a locker that we did for the Department of Defense without using active fire suppression at all. It comes down to the application and what we're trying to control. And that goes back to us really deep dive assessments, better understanding our risk that I talked about in the first couple of slides.
Sure. No, and I think that's great. And I think, again, I mean, you know, if anyone has questions, please let me know. I mean, you know, honestly, if you guys want, you know, if Ron wants to answer, I'm happy to answer as well. I mean, I think at this point, I'm going to get into a little bit of, like, based on what you were saying, right? Like, I mean, you know, a lot of the reasons why, you know, these, I'm showing the early detection and response. That's why the goal is to, you know, to try to set the tip wire or the tripwire early enough in the process as possible, and then try to create the pre-incipient stage, which, again, I mean, if you guys follow me on LinkedIn, there's a couple of fire engineers that might not agree with the pre-incipient stage, but we do, right? So, you know, the idea again is, you know, if you're focusing at this from a waste and recycling perspective, you need to plan for that prevention piece. And then the professional response is, you know, and I think, you know, Ron gave a pretty good insight on, you know, the things that they're dealing with, right? So, you know, not only do they need to understand your facility, and not only do they need to have the right equipment there and available and ready to go, you know, these are the things that you can control. The internal response, you can't control it. Like with a system and solution like ours, we can control this, right? And again, when I say control, you know, firefighters can't control fires, right? I mean, always, there is no guarantee, right? So, you know, I know Ron's former firefighter. I think, you know, from our perspective, you know, it's, they don't want to fight a fire if they don't have to, right? I'm sure you probably violently agree with that. So, you know, if we can catch it, and when you're dealing with lithium ion, if we can catch it from a heat abnormality and know that something's going to happen before, we can try to do something with it, right? So, you know, and again, to me, it's really about videos. So, you know, which ones are, you know, kind of the videos that show, I mean, this is a lithium ion battery that, you know, literally right there, you just saw that was an explosion, right? We can watch it again. So, you know, again, there's also rats in the corner. If you guys, that's always fun to watch from a thermal perspective. But
Burn.
again, it goes in, we're going to hit it. Now, whether we hit this with water or the encapsulator agent, I mean, you know, as long as we soak it, we're probably in good shape. The reason, you know, we prefer an encapsulator agent is that it actually makes, it's like 150 times wetter than water. So it will make the material around this so that it can't burn. And again, when you're dealing with a block of lithium ion batteries, or, you know, that's different than when you're dealing with a lithium ion battery amongst MSW, right? And I think, you know, that's one of the things, our goal, and Jim Emerson will talk about this next week, is that, you know, you should never go in and basically lift a fire out of a tip floor or a tip pile, right? You should pre-wet it and do everything you can to soak and not bring oxygen to that fire to make it worse. So again, we can kind of get into that. I mean, this is another kind of example of um, this one I think is good, because what it does is this will show this was a hazard material facility, but, you know, we can see that there's no flame yet. We're seeing that this is starting to cause an issue, and what we're going to do is we're going to spray it with our, you know, with our agent, and make sure that at least number one, we can control, you know, what the temperature is on it and what's going on with that temperature, and is it a harm to someone. So you're going to see there's an employee that will pop in over here. You know, and again, from our perspective, what we want to do is get a targeted spray, and I think that's what's different than most other systems out there. You'll see right here, so we actually have communication. We're going to spray it. We're going to make sure that we're going to make sure that that the that the risk and the hazard has been dissipated, right? So you'll see, like, this is a targeted spray. That's our nozzle right here. We're going to shoot it. We're aiming it from our agent who is remote. And again, we'll hit this, and you know, we'll also see, and we know if, because we have fire watch, right? So we're going to see if this thing, you know, has another issue, or is it safe to go in and try to remove it as quickly as possible. Again, this is a chemical. This isn't a lithium-ion battery, but I think the approach is always similar. You know, and again, I think to what Ron had said, you know, there's a few different solutions that we are now offering that are being driven by the industry and by the need. And again, you know, of course, we'll do thermal only. We do the Fire Rover system. What the Fire Rover sprinkler replacement, and what's nice about this is that, you know, for lithium-ion battery operators, where we're dealing with the larger, you know, types of lithium-ion batteries, firefighters don't want to go in and fight these fires. So we've actually created a manifold so that our system will shoot for 6 to 12 minutes, and then the fire department can quick connect from the outside, you know, hook to the hook to the fire extinguisher and still pump water through. So we just did one for a large automotive OEM, and you know, now we're able to hit it in 6 different locations, and we can shoot for as long as that they have access to water. And again, then we've developed the Fire Rover deluge system, where we can actually put our system onto an existing sprinkler system. Again, we like to have a different infrastructure on it, but this is for the large deluge waste to energy types of facilities and paper storage. So again, just to kind of get into that, is there any other questions that you guys would like to ask? I just kind of popped it in the text. David Rivas has a question. David, you have a lot of questions today. I love
it. Can you hear me, Brian?
Yeah, we can hear you. Not great, okay, but we can definitely hear you.
Perfect. Sorry about that. Quick question. The lithium-ion batteries that are contained inside devices. A lot of OEMs nowadays, they use a very thick adhesive glue to keep the batteries inside. One of the practices in the industry that we're in is the freezing of the entire device, and it somewhat freezes the glue, and we're able to pop those out. My question is, does that cause a risk, a potential risk with the battery, the chemical making the battery, if you're actually freezing it, let's say, for a few hours or overnight?
That's a good question. I couldn't tell you affirmatively or otherwise that that's the case. That'd be an interesting case study. If you see that it works and it's good practice, and you have a standard operating procedure that reflects this process, I would continue to use it. What I would say is, one of the problems we've seen, I know the reason why you freeze it, one of the problems we see is that because they're glued, when they physically rip the battery out of the case for repair or recycle, that's when the problem starts. And we have video after video after video that shows that. So I'm glad you're doing something to intervene. I don't know if there are any studies that would support or refute what your process is, i.e. the freezing process. But it sounds reasonable to me. Has it reduced? My question to you would be, have you seen a reduction in issues?
We have. We have. My concern was, you know, how long do we leave it in there? I mean, obviously, the longer you leave it in there, the harder the glue becomes, the easier it is to pull the device out. You know, but wishful thinking is, hopefully one day the OEM realize you don't need to use a very super thick glue to keep those batteries in place. The old school devices, they use screws, and those work, you know, fine. But back to just rating the risk. My other question is, if you allow me, is a swollen battery. You know, the EPA doesn't really define what a damaged battery is. You don't see swollen as being one of those terminologies. A swollen battery from a risk rating, if you still properly package it and ship that out, what's the risk of that?
To me, it's compromised. I personally consider every battery that's removed from any used piece of electronics that's compromised. Now, there are different levels of compromise. You mentioned the swollen battery, so there's an obvious physical deformation that has occurred, and you absolutely need to take that as a sign that it's compromised and treat it accordingly. How do you move those things to and from? I'm not expert in that. The rules elude me. I know the basics, but the best way to do it to me would be in a containerized system, and I wouldn't ship one if I could possibly get around that. And the bigger question is, how do you store them? Once you pulled it out and you see that it's deformed, would you just leave it on the table? You leave it on a shelf somewhere? It sounds like your organization is really progressive and thinking deeply about this. The next step in that thought process might be, is there a locker I put it in for safekeeping until I can move it? Because you've recognized that there's a deformity, and if it's not normal, then I can just make some assumptions about its risk profile.
Cool. So, again, I just would like to let everybody know. I mean, again, we'll stay on and do questions. I mean, I have some more time. I think Ron does as well. So, again, I appreciate everybody taking the time. There is next week. We have Jim Emerson. We're going to talk through the combinational approach. So, I mean, you guys, I'm sure if you heard me before, I'm exhaustive. Everybody needs a fire plan. These days, you have to have a fire plan, period. Insurance companies are requiring the fire plans. So, what you can do. And also, Chris actually just shared an EPA, Chris Newman, who's with EPA. He just shared a link as well on the safe packaging and transportation of lithium-ion batteries. But, I will say this, and Ron, you can kind of jump in, but this is, believe it or not, a very early industry, right? We are on the early curve. A lot of people, lithium-ion batteries, believe it or not, are we're only getting more of these, right? And I think, protection and other things, I mean, we're in an early infancy. We don't know, fire departments don't know what they're supposed to do when there's a lithium-ion battery operation that has a fire, right? They're not trained well. And, again, it's not their fault. And a lot of times that's what's causing them to take the defensive approaches. So, I think this is definitely an early industry. I don't know, Ron, what's your thought on that?
I think that's a great point. It is early, and that's hard for people to believe. But the amount of batteries in our possession worldwide is going to grow dramatically over the next 5 to 7 years. If you pay close attention to the industry, every day you see some press release coming out of a university that they've come up with the next best thing that's safe, perfect. It's not going to happen for a long time. Lithium ion is queen for a long period of time and beyond, because we're going to be dealing with them and recycling them for the next 12 years. We have to know how to plan for it. You'd better have a really good standard operating procedure. You better have a really good emergency response procedure. Keep people out of harm's way. And you might even, glean some insurance underwriting benefits. I'm sure, there are some insurers that would look at you, very favorably if you have your plan, your stuff together, so to speak. If you really have your stuff together, there's some companies that would look favorably on that, and you can negotiate better insurance rates potentially.
Well, yeah, and I think, what we're seeing is that insurance rates are actually they're skyrocketing. If you don't have them, you're not going to be insurable, right? And so I think Jim Emerson from next week, he's with Starboard Technical Risk Agency, and they were started by the guy who had started AIG. So, they're one of the big insurers out there for large risk. Jim will go to hydroelectric plants and places that I wouldn't even know how to start, right? And most fire engineers wouldn't know how to start figuring out the issues that they face from a risk mitigation perspective. So is there anything else? Thanks, Megan, we appreciate it. Is there any other questions or anything else? I'm going to leave Ronald's number. It's info@eCellSecure with a dash. Obviously, if you guys need his information, just let me know. He's on LinkedIn as well. But please, next week, I think it'll be a very interesting webinar with Mr. Emerson and myself. Unfortunately, you have to still deal with me. So, and then Ron, if you want to do another in a few weeks, let's figure out what the next level would be. And if anyone has any suggestions, please send those off.
Cool. Well, thanks for your time. I appreciate it. I think what you're doing, Ryan, is outstanding. I hope people are taking, not only what we teach, but what we learn. I try my best to learn every day, and there's always something to learn. to heart and you know, make it work for them. Use the tools that are available. Think of tools that are not. Process, process, process.
100%. Now that's why I call you the Jedi Master of Lithium-Ion Batteries. If anyone disagrees, please speak now or forever hold your peace.
Don't say that, because you'll be flooded with who's this idiot?
Nice.
But it was my pleasure. Thanks for having me.
All right. Thanks. I appreciate it. Bye.